Hi students, in this video we are going to solve more integral problems related to trigonometric functions. I'll read out the question now. Evaluate integration of tan square x dx, and the second question is integration of cot square x dx, and the third question is integration of sin square x by 2 dx. First I will tell you how to approach this problem. The first question is integration of tan square x dx. We do not have any direct formula for tan square x, so we cannot apply any direct formula. It has to be rewritten. If you look at the integral formulas, we have formula for integration of secant square x. So using that formula only we can solve this. So this tan square x should be written in terms of secant square x. We know that in trigonometry we have the formula 1 plus tan square x is equal to secant square x. Using that formula we can write tan square x as secant square x minus 1. So we can apply secant square formula. Similarly here we do not have any direct integral formula for cot square x, but we have the direct formula for integration of cosecant square x. So we know that this cot square x can be written as in terms of cosecant square x. We can write cot square x as cosecant square x minus 1, by which we can solve this. For this problem, sin square x by 2, angle is x by 2. We don't have actually any formula for square, sin square x, but here we have x by 2. Using this hint, we can say that we can apply cos 2a formula, because we have cos 2x is equal to 1 minus 2 sin square x. Using that concept we can solve the third problem. So now we will see the solution for one by one. First question is integration of tan square x dx. You know, I already explained you that we have direct formula for secant square x. Hence we have written this tan square x in terms of secant square x, that is secant square minus 1 dx. You know that these two this integration can be done separately. So integration of secant square x minus 1 into integral of dx. Integration of secant square x dx is tan x. This minus sign as it is. Integration of dx is x. So tan x minus x plus c. I hope you understand this first problem easily. Similarly, second question, integration of cot square x dx. We do not have any direct formula for cot square x, but we have direct formula for cosecant square x. So we rewrite this cot square x using trigonometric formula, that cosecant square x minus 1. We know that these two terms can be integrated separately. So integration of cosecant square x dx minus 1 into integration of dx. We know that integration of cosecant square x is minus cot x, and integration of minus 1 dx is minus x, and then plus c. I hope you understand this second problem also. And then we will move on to the third problem, integration of sin square x by 2 dx. We do not have formula for sin square x, so we are going to apply this concept. Cos 2a is equal to 1 minus 2 sin square a. Hence we can write sin square a as 1 minus cos 2a divided by 2. We have used this formula in inverse trigonometric functions and differential calculus many times, so you will be very comfortable with that. And one more thing I want to emphasize is, here if we have angle 1a means here we have angle 2a, so we have to write the twice the angle here. So similarly, integration of sin square x by 2 dx can be written as 1 minus cos. Here we have x by 2 means double the angle is x. So 1 minus cos x divided by 2 dx. We can take this 2 outside. So 1 by 2 integration of 1 minus cos x dx. We know that these two terms can be integrated separately. That is integration of 1 dx minus integration of cos x dx. Integration of 1 dx is x minus, and then integration of cos x is sin x. Hence we have this half into x minus sin x. When we multiply these two inside the bracket, we get x by 2 minus sin x by 2 plus c. I hope you understand these three problems very clearly. These are some of the important 2 mark or 1 mark questions. Now we will move on to the next question. Evaluate integration of root over of 1 minus sin 2x dx. Here we have the square root. First the square root should be removed. After that we can simplify this. In order to remove the square root, we have to bring some square function here. What we can do is, first we will rewrite this sin 2x as 2 sin a cos a, and then this 1 can be written as sin square x plus cos square x. So just see this. In the first step we have written the formula for sin 2x, this 1 minus as it is, and then this 1 has been written as sin square x plus cos square x. So root over of integration of sin square x and cos square x. Sorry students, here I missed this integration symbol. Now if you look at this, it is in the form of a square plus b square minus 2ab. So we can write integration of square root of a minus b whole square. This square and square root will get cancelled. We have integration of sin x minus cos x dx. These two terms can be integrated separately. So integration of sin x is minus cos x. This minus sign as it is. Integration of cos x is plus sin x. I have taken minus sign as it is, that is minus 1. So we get sin x plus c. So in the next step I have written sin x plus cos x, but I didn't write this minus 1. This minus 1 has been added with some integral constant. We get the another constant. So with that final constant is mentioned as c here. I hope you understand this problem also. Now we will move on to the next type of problems. This is an important problem. This type is very important. Evaluate integration of dx divided by 1 plus sin x. In the numerator we have only 1, but in the denominator we have 1 plus sin x. We have two terms. It is binomial expression. Just check it. Similarly, in the second problem, in the denominator we have binomial expression, that is two terms are there, right? Whenever we have more than one term in the denominator, it will be difficult for us to solve the problem. So please understand this concept clearly. What we have to do is, in the denominator we must bring only one term. We must convert binomial into monomial. So we will have to look for a formula to convert binomial into monomial in the denominator. So what we do is, we multiply numerator and denominator by 1 minus sin x, that is conjugate of this. So in the numerator we have 1 minus sin x dx divided by, here if you look at it, a plus b into a minus b. So we have 1 square minus sin square x. So in the numerator we have as it is 1 minus sin x dx, but in the denominator we can write 1 minus sin square x as cos square x. Now it is monomial, but in the numerator we can have binomial, trinomial, like that we can have many terms. But in the denominator, if we have only monomial, means we can separate the fractions and then we can do the integration easily. That's why I told you, in the denominator if you have binomial or trinomial, you must try to convert them into monomial using any technique. Here we applied one conjugate technique to get this. So we can separate the integration as this fraction as 1 divided by cos square x minus sin x divided by cos square x. This cos square x has been written as cos x into cos x. We know that this 1 divided by cos square x can be converted as secant square x, because we have direct formula, integration formula for secant square x. So integration of secant square x dx. So we got integration of secant square x. This sin x by cos x can be written as tan x, and then 1 divided by cos x can be written as secant x. So we got integration of tan x into secant x. Here now we have direct formula for these trigonometric functions. So integration of secant square x dx is tan x. Integration of tan x secant x is secant x. We just write the final formula to get the answer. I hope you understand the first problem clearly. With the second problem we will complete this video. If you look at the second problem, again in the denominator we have binomial expression. It has to be converted into monomial. In order to do it, we are multiplying both numerator and denominator by 1 minus sin x, as we did in the previous problem. So in the numerator, when you multiply the sin x inside the bracket, we get sin x minus sin square x, and in the denominator we get 1 square minus sin square x. We know that denominator can be converted as cos square x. After converting the denominator from binomial to monomial, we can separately write the fraction. So the question becomes integration of sin x divided by cos square x. Here for our convenient, I am just writing it as cos x into cos x dx minus sin square x divided by cos square x dx. This sin x divided by cos x can be written as tan x. This 1 by cos x can be written as secant x, and this can be written as tan square s, integration of tan square x. In this video, the first problem is integration of tan square x. We can apply that concept here. So integration of tan x secant x is secant x. We know that integration of tan square x dx, the first sum in the video, we cannot have we don't have any formula for integration of tan square x, but we have the formula for secant square x, so we converted into integration of secant square x minus x. So when we do the integration, we get tan x minus x, and then we multiply this minus sign inside, we get this answer. I hope you understand all this problem clearly. Thank you students, thanks for your cooperation.